Well, let's look a little closer at the tangent function. And in this couple of exercises, we're going to look at reflections and translations or phase shifts, horizontal translation or a phase shift. And the first example, and actually I did this first example piece by piece. But where we're going to get to in this first example is where y equals the tangent of 2x plus pi over 2. But first, I just graphed y equals the tangent of x. And, of course, our domain is going to fluctuate between pi over 2 plus n pi, where n is an integer, so it's multiples of the integer of pi plus pi over 2. And we're going to have a period, our period, and that's what I want to focus on here, is pi. And we're going to have infinite discontinuity at, well, let me say where I got my scale here. I've got the x minimum at negative pi, I've got the x maximum at pi, and I set the scale to pi over 2 so that we could focus really on this period. But why do we have asymptotes, infinite discontinuity at pi over 2? Well, if you think about that unit circle, and if tangent is equal to y over x or sine over cosine, when we get to pi over 2 on the unit circle, sine is equal to 1 and cosine is equal to 0. And of course, we can't divide by 0. It's undefined. And so we have undefined points at negative pi over 2 and pi over 2. But if I think about the period, and of course, period thinking about a distance, well, the distance between this and the vertical axis is pi over 2. And from here to the next asymptote, I should say from one asymptote to the other, is also pi over 2. Well, pi over 2 plus pi over 2 is 2 pi over 2, or the period is just pi. And that's what we see here in this graph of y equals tan, not 10, tan, the tangent of just x or theta or whatever. All right, so there's our period, and of course our range is going from negative infinity to infinity. If we use this as a starting point, and here's a starting point, again, the distance between those two is pi. So we have a period of pi. Now let's take the next step in this. This time I've graphed y equals the tangent of 2x. Now 2, of course, relates to b, and that affects our period. And our period then is adjusted by this formula, pi, because that's our period, pi, for the tangent function. It's 2 pi for the cosine and sine function, over the absolute value of b, which in this case is 2, or our period here is pi over 2. Now, that's also going to affect our asymptotes. And it's going to change them from pi over 2 to pi over 4. So I see two changes in this. I see a change in the period to pi over 2. And if you think about it, in our first example here where we just had the tangent of x, our period is 5, but we saw asymptotes occur at the halfway points, at the midpoints between pi. Negative pi and 0, we saw an asymptote at negative pi over 2. And between 0 and pi, we saw another asymptote at pi over 2. And so my asymptotes here are no longer pi over 2 in this transformation, but it is at pi over 4. And I can see that because, again, my scale here, this is negative pi, this is negative pi over 2, and I'm seeing an asymptote come right here about halfway in between, and I'm seeing another asymptote down here at halfway in between, and another asymptote right here. This would be at pi over 4. And right here, this would be, I'm going to draw an asymptote over my face, that would be 3 pi over 4. And so not only does this change our period, but it also changes and moves it scrunches upward, if you will. It has horizontally compressed, I guess we could say, our graph. And so our asymptotes now are at pi over 4. And this negative pi over 4, negative 3 pi over 4, but we see it in intervals of pi over 4. Now let's get to the actual full transformation of what we were considering, where we got the tangent of 2x plus, is it plus? Yeah, plus pi over 2. All right, and so here I graph in the blue is the tangent of 2x, and in the red we see the tangent of 2x plus pi over 2. And this pi over 2 has given us a phase shift. All right, so how has it shifted? Well, if my original asymptote with the tangent of 2x, maybe I should have done this on the previous slide too. If it's x, let's say, minus x over 4, pi over 4, I mean, and we're going to set that equal to what our asymptote was, which was pi over 4. Oh, I know. I need to get to do the definition of the phase shift. Excuse me. Let me back up. This phase shift is C over the absolute value of B, with pi over 2 in this case representing C and 2 representing B. And so I've got pi over 2 divided by 2, which is the same as pi over 2 multiplied by 1/2, and therefore that's why this is pi over 4. So we're going to see this phase shift of pi over 4. And I do see that there in the red. If I look right here at the origin, where we cross the origin, and if this is negative pi over 2, well, you can see there in my transformation, I've shifted, in this case, negative pi over 4. We have shifted to the left by pi over 4. This factor, where did I put that? Right here. And there's our phase shift. Now, but what's going on with my asymptotes? My period has not changed from when we had the tangent of 2x. My period is still going to be pi over 2 rather than pi, which it would be if I had no transformation at all, if I was just graphing the function. So let's see, let's set this x equals negative pi over 4. There's my phase shift, and my previous asymptote, let's say we had one at negative pi over 4. All right. Well, what's happening here? If I add pi over 4 to both sides, then I should see an asymptote at 0 at the origin. And I do see, from the red I'm talking about, an asymptote running right there. Now what about to the right of that? Well, let's see if I had x. Well, actually, like I say, we'll go to the, yeah. If I had x minus pi over 4 equals pi over 4, and then I add 2 to both sides, what's going to happen? I mean, pi over 4 to both sides, well, then x is now equal to 2 pi over 4, or pi over 2. So I found this asymptote at 0 at the origin, x equal to 0, and I should see another asymptote at pi over 2. Is that right? Where's my other one? Well, we'll go negative pi over 2. We'll go in this direction. And I see an asymptote occurring right there at negative pi over 2. And on this side, on the positive side of the y-axis, I see an asymptote running right here at the origin, and I see one at pi over 2. And so that's the effect of our phase shift. So the 2x affected our period, changed it from pi to pi over 2. And in this example, the plus pi over 2 gave us a phase shift to the left of pi over 2. Moved my asymptotes from, let's say, negative pi over 2 to 0, and I got another one from 0 out to pi over 2. Now let's look at one more example before we head off, and I think we're going to look at cotangents here in a minute. All right, so here I had, and I just graphed this all at one time, and I've got two transformations taking place here. So I got y equals negative tangent of x minus pi over 6, and the x minus pi over 6 in parentheses. Well, my first transformation is this negative right here, and that's going to give me a reflection. It's going to flip it over the y axis. And you can see this is flipped. This has gone from here to here and from here to here. So we have flipped this thing over the vertical axis. I don't have any change in the period. So my period goes back to where my parent function of this tangent function, which is pi. But I do have a phase shift here of negative pi over 6, which is going to give me a phase shift to the right by pi over 6. Now, if you notice right here we had an x-intercept at the origin, 0, 0. And now I've got an x-intercept right here. And I used my find the intercept value in my calc function of my calculator to try to find the x. I was really focusing on the x coordinate of that intercept. Of course, you can see y is equal to negative 402 times 10 to the power of, that's double digits. So it's pretty close to zeros, and it's not exact. But you see that I've got an x-intercept here at 0.5235988. And I challenge you, go into your calculator and put in pi divided by 6 and see what you get. And I think you'll find it's pretty close to that figure right there, 0.5235988, or pi over 6. And there's my phase shift, and I shifted to the right. This is a phase shift to the right by pi over 6. That phase shift was a little easier to see. Maybe it's because I wised up and used the intercept. But anyway, so there we go. We've taken a look at some reflections and phase shifts or horizontal translations of the tangent function.